Hi, fifth graders. Let's review for the Unit 5 test. Make sure you pause the video when I ask you to, so that way you can try to solve the problem on your own. Let's get started. The first type of problem you might encounter is a word problem. I'm going to model the mathematician's plan starting from step 1, which is reading the problem. Marvin's home is 7/8 of a mile away from school. He stopped at the gas station to get a bag of chips when he was 1/2 of the distance home. What fraction of the distance home was he when he stopped at the gas station? All right, I'm going to zoom out, and I want you to pause the video and read it once on your own. Think about how you might annotate the problem. All right, here's how I would annotate the problem. The first thing I'm going to do is I'm going to circle the numbers that I see. Numbers includes fractions, of course. I'm going to circle 7/8 and 1/2. Those are the only numbers I see, so I'm going to move on to underlining key words. I know that of is a key word for multiplication, especially when we see it next to a fraction. If I need to find 1/2 of something, I'm going to multiply it by 1/2. So I know I will be multiplying my two numbers. I'm also going to underline the word gas station, because that's what my 1/2 represents. The final thing I'm going to underline is fraction. I'm underlining fraction because that tells me that my answer should be less than 1 whole. If my answer is greater than 1 whole, then I know I need to check my work. Now I'm going to star the unit, which I think is miles. So I know my answer should be a fraction of a mile. Now pause the video and try to write your own equation to match the problem. All right, hopefully you wrote your own equation. So now here's what I would write. I would write 7/8 times 1/2 equals m. Did your equation match mine? Pause the video and try to solve this on your own. Here is how I would solve it. I'm going to start by using a visual model. I'm going to draw kind of a long visual model because I know that one of my denominators is an 8. So I'm going to need a lot of columns. I'm going to start by making 8 columns. 1, 2, 3, 4, 5, 6, 7. Oops, I drew one extra line. 7 and 8. Then I'm going to divide that in half because my second denominator is a 2. Now, the problem was talking about 7/8. So I am going to use this to show that I'm using 7/8. And I can label that just like that. Then I'm also going to represent that I'm multiplying it times 1/2. So I'm using 1/2 of those 7/8. Then I'm going to color everything that fits in this rectangle. I saw a student in Miss Christie's class using dots, which is a really great lazy mathematician strategy. To find my product, I am going to count the total number of squares for my denominator. Since I'm a lazy mathematician, I'm going to use skip counting. So I have 2, 4, 6, 8, 10, 12, 14, and 16, which is my denominator. The denominator of a fraction always represents the total number of parts. Then I'm going to count the number of shaded squares, which is my selected number of parts. 1, 2, 3, 4, 5, 6, 7. So 7 is my numerator because my numerator represents my selected number of parts. Now, the next step is to check your work with the second strategy. I want you to pause the video, and no matter which strategy you chose, I want you to choose a different one. For my second strategy, I'm going to represent my thinking with an algorithm. So if I'm doing 7/8 times 1/2, I know that is the same as doing 7 times 1 over 8 times 2, which means that my numerator should be 7 and my denominator should be 16. So those are two strategies to represent my thinking. Now, before I turn in my work, I would write 7/16 of a mile. Now that would be some A+ level work. Here's the next practice problem. Let's do 74 times 2/8. It's been a little bit since we've worked on multiplying fractions times a whole number, so this is a great time to review. I want you to pause the video and try this on your own. All right, here's how I would approach it. I'm going to use a ratio table to represent my thinking. So I'm going to start on one end with 1 times 2/8. On this end, I'm going to show that I'm trying to reach 74 times 2/8. I don't know what the answer to that is yet. All right, the first thing I'm going to do is I'm going to build my magic numbers. So I know I'm probably going to need a 2. And that's pretty easy to find because 2/8 plus 2/8 equals 4/8. I know this because when I'm adding fractions, I do not add the denominator. The denominator stays the same. I'm only adding the numerators. So I can use that thinking when I'm using multiplication. So now I have 4/8. The next thing I'm going to do is I'm going to find 10. I think that if I added 2/8 10 times, that would be the same as 20/8. Like I showed before, if I'm using repeated addition, my denominator should stay the same. I need to get to 74. So the next thing I'm going to do is I'm going to take the product of 10 times 2/8, and I'm going to multiply that times 7 to find 70 times 2/8. I know that 7 times 2 is 14, and I'm finding 70. So my answer is going to end in a 0. And just like always, my denominator should stay the same. All right, the last step is I need to get to 74. I'm a lazy mathematician, so I'm going to try to do this in as little steps as possible. The first thing I'm going to do is I'm going to find what 4 times 2/8 is, because I can add that to 70 times 2/8 to get my answer. I know that 4 times 2 is 8, and that should be over 8 still. The last thing I'm going to do is I am going to add 70 plus 4 to get 74, which means I'm adding 140 over 8 plus 8 over 8. My denominator stays the same, so if I add my numerators, I should get 148 over 8. Another way that you could think of this problem is by picturing that 74 has a denominator of 1. If a number has a denominator of 1, that means it's a whole number. So, if I do 74 over 1 times 2/8, I know that all I have to do is multiply my two numerators and put them over the product of my two denominators, and I'll use standard algorithm to do 74 times 2. So I have 4 times 2 is 8. 7 times 2 is 14. So I know that my answer is going to be 148 over 1 times 8, which equals 8. So those are two ways that you could show your thinking for this problem. All right, here is one last problem to review. Let's look at 3/9 times 2/5. Pause the video and try this problem on your own. All right, first we're going to use a visual model. I'm looking at 3/9 times 2/5. I'm going to make a pretty long model. If I know that I've got a big denominator, I'm going to need a nice long model. The next thing that I'm going to do is I'm going to create 9 columns. I know I need to create 9 columns because I have a denominator of 9. So I'm going to create 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then I need to create 5 rows. 1, 2, 3, 4, and 5. Now I'm going to use my numerator to determine the dimensions of my rectangle. The numerator for 9ths was 3. So I'm going to be using 3 of my 9ths. If I really want to show good craftsmanship, I would label that represents 3/9. Then I'm going to need 2/5. So I'm going to use this to show that I'm using 2/5. Then I'm going to use some sort of shading to show that those squares are within my rectangle. If it helps, you can draw a line to represent the rectangle. For my numerator, I'm going to count the number of shaded squares. So I have 6 shaded squares. The next thing I'm going to do is I'm going to count my total number of squares. And I can use skip counting for this. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So I have 45 as my denominator. Here's another way to think about that problem. I could think of 3/9 times 2/5 as the same as 3 times 2 over 9 times 5. And if I know my single digit addition, I know that 3 times 2 is 6 and 9 times 5 is 45, which is my final answer. Thank you so much for practicing with me, 5th graders. If you got all the way through this video, I want you to get a sticky note tomorrow morning and draw a doodle of your favorite animal. If you bring me a Post-it with your favorite animal on it, I'll know that you watched the video all the way through and you will get a prize. All right, thank you for watching and I'll see you tomorrow.